Hello everyone. So welcome to this new stream of CloudNext On Air Extended. It's an awesome event curated by 12 plus communities of India. Today, GDG Nagpur is taking the helm for curating and hosting the stream. So I'd like to welcome Sohel, who is an organizer of GDG Nagpur. Hey Sohel, how's it
Hey
going?
everyone, a very fresh morning to all of you.
Yeah, so
So,
by the way, I guess today is Friendship Day as well. So happy Friendship Day to everyone.
yeah,
I
happy
guess you
Friendship
might
Day.
be enjoying, so I guess they might be enjoying a long weekend as well. So it's
Well,
a 3 days
well, we
long
are
weekend.
celebrating friendship of our community. We can say that.
Yeah, yeah. So before we get started, good morning to everyone. And once again, welcome. We are going to have two sessions today, both of them speakers are awesome and very eager to join the stream. So before we start, let's just have a bit of chit chat with Sohil till everyone is ready and have joined the stream. So, hey Sohil, so what are the what is your job description, or you can say what are the technologies that you are working with?
Okay, so well, I belongs in the Android segment. I can say that. Fortunately, I became an Android developer, and currently I'm working on Firebase. So, in our organization, we have an official app, and currently I'm contributing on it.
Yeah, so Firebase itself is a very interesting thing. I personally like Firebase very much. So, like, what is your finding? Like, how are you finding working with Firebase? So, it's also, we can say it's a part of Google Cloud as well.
Yeah.
So,
So, as an Android developer, I can say Firebase is something really magic for us. Okay, when it comes to build a small app, I can say uh, everything you are getting in a place. Specifically, I am fan of Cloud Firestore and the authentication feature, where you don't have to worry about the session things. Firebase do manage everything by its own. Okay, and it comes to the Firestore. Okay, yeah, don't need to worry about, you can say, functions that Google have provided a well documented SDK. When we talk about functions queries, it's really easier. And the one of the feature that I like about the Cloudflare stories, I can say, security rules. Okay, the actually hierarchical database that you want to organize, and it's really, you can say, very easy to do with that. So yeah, I'm personally fan of this thing. And you can say the add-on things like analytics service, which you can get a whole the user reports on, you can say, in front of you. It's really easy. Like, it's really save the time of an Android developer, and as well as, I believe, for web developers as well. Well, you are working on a web, I guess, and you must have used Firebase, so
yeah,
you must
yeah.
have enjoyed it.
So I am like more potentially Angular and a Flutter developer. I work this Firebase on both the platform, right? So what I find very interesting about Firebase is a guy like me who doesn't know how to write SQL queries or how to perform any operations on SQL or even how to install SQL on my system. Firebase is really, we can say, a bless for people like me. So, like, without having to rely on anyone, we can create small apps or even larger scale apps. So, there is a misconception that I want to fire, right? That people generally say that Firebase is really good if you want to prototype apps, but when you are taking any apps to scale, it cost you a lot. But I guess it at the end of the day, it really what really matters is how you are performing your read and write operations. Right. So for example, if you are iterating through a list and updating all the list instead of like what I've seen many people do is they will fire a write command for each and every entry of that list. Right. So that's particularly a bit weird. So just only thing you need to care of is like whenever you are writing or updating something, create a batch for it and then commit the whole batch to the DB, right? If you are not observing any triggers on that particular column or collection, right? So it's very easy to manage DNS. There are also some tools which are available, which you can like tunnel through your server, which will like decrease your reads and writes, right? So they'll basically cache the data for you on your server, and then your server will basically connect to Firebase. There are many tools available. I have tried once So there one of my friend whom I met at FS Bangalore last year was developing this kind of extension for basically Node apps, or there was other platform, but I don't remember. But it was called Fireswiss, right? So it gave you all sort of utilities to work with Firebase, and it was particularly so much interesting. So while we get started with the stream, let's see some comments. So GP says good morning. Akshay Malavya also says good morning to everyone. Good
Good
morning to you,
morning.
Akshay. And there is another comment by Saurabh who is wishing us a happy Friendship Day. Right.
Yeah, happy
So happy
Friendship Day.
Friendship Day to you, Saurabh, as well. So I guess we are ready for our first speaker, who is Praveen. Right. So let's add him to scene and have a bit of chat with Praveen before we start this session. Hey Praveen, how's it going?
Hey, Pat, I'm doing good, and it's a beautiful Sunday morning as well, and I'm very excited to get started today on CDN.
Yeah.
So,
Yeah.
thank you for
So
bringing this new initiative, and it's really good to see communities getting together and planning such a big event, which would be useful for many type of people. Great move.
so much. So can you tell a bit about yourself? How it got going and what is some cool things that you are currently working on?
Okay, so myself, I'm Praveen Thirumurugan. So currently, I'm a software development engineer at Caterpillar Inc. And previously, I was working at Trimble Incorporation as well. So apart from that, I mean, I'm the founder for GDG Cloud Coimbatore community, and it's been more than 2.5 years since working with GDG Cloud, and also I've been part of GDG Coimbatore for the past 6 years. So I have a good round of knowledge on how community works in my region and also across the country. So after that, so basically my passion is for cloud. So I work more on GCP, AWS as well, and so for the past 3 years, I've been closely working with GCP and building applications and helping people scale their apps and by giving recommendations on which features to use in GCP, etc. And currently, I'm also working on a new product called as REST Labs. So it is an URI monitoring tool and REST API monitoring tool. So we are targeting it for smaller teams who could get started with monitoring very easily. So that's my background part.
Yeah, yeah. So I guess you can send us the details and we can put them in the comments and description. So people who are interested in that tool can also try check it out and you will get some awesome feedback from my audience as well.
Yeah, sure, sure. It would be great. I'll do it in a couple of minutes. Yeah.
Yeah, so I guess I am taking up too much of time from the audience who are here to listen to you, not me rambling on about things. So let's get started with your session, and I am leaving the scene. Mike is over to you. Bro. Thank you so much once again for joining us on this Sunday and long weekend. Yeah,
What
so
negates was
Praveen,
the
there
noise.
is hello, Praveen. There is some audio issue from your end.
Okay. So can you hear me right now?
Yeah,
I'll
yeah,
be
we
a
can
little
hear
bit
you fine,
louder.
right?
Yeah. So let me
Yeah,
go
sorry
again.
to interrupt.
So
I'm dropping off.
no, no issues, no issues. Yeah. So I'd like to welcome the audience currently. So thank you so much for joining on a Sunday morning, and it's very good that you're showing so much interest on learning new technologies and also adopting cloud in your own businesses. And I'm also very surprised that many students are coming up with their own solutions in their college, and they're using the power of cloud solutions like GCP to get started their project. So it was very bit different 4 years ago, and it's very different. So students on second years, third years are showing so much interest on learning new technologies like CDN or EC2. I mean, cloud storage, etc. So today we are going to see about a new topic called a CDN. So CDN is content delivery network. So Probably you have seen about GDG Nagpur's post on Twitter and LinkedIn, etc. So how Netflix and optimizes their storage mechanisms and provides you video streams very fast, instantly without any buffering. And also you could take YouTube. So it is very fast, right? You go to the YouTube app, open a video, and it starts buffering. I mean, it starts to load instantly, and you do not face any buffering time at all. So how is this happening? The original data store, actually the database is actually stored in US, but once you access in India, you don't feel any lag at all. So these are all done taken care by the CDN delivery by Google. We are also going to see how CDN helps your business and your product to be very fast, and you could provide very fast experience for your customers. So let's get started today. Okay, so the agenda for today would be like this. So we would see what is a CDN, and we would talk about what is CDN in Google Cloud. So there is a feature called as Cloud CDN in Google Cloud. So we'd be talking about it, and we would also do a small setup demo on Cloud CDN today, and we would go through the screens on how to set up Cloud CDN in GCP. And also we'd be discussing about the benefits of CDN in GCP, and also the security features that comes along with it, and then we would be wrapping up for the day. So I'm sure that you'll be able to grasp some of these things today and experiment yourself, so that it would be great for you, for your career, and also you could potentially use these learnings in your own product. So, all right, let's go ahead. So, what is a CDN? So, CDN is a content delivery network for the abbreviation. But if you see this image right here, so there is a image on the left and the right side. Think of this left side image as the center part, the CPU kind of database as a common data center. For example, you could think it of like a data center at US North, and think of these computers around it as end users. For example, Netflix has the server in the US North, and these computers are the users or subscribers for Netflix. So what they do is they try to view the videos which is available in Netflix, but all the video content are being directly streamed from the data center. So what it leads to is it gives poor performance for all the users, and users would start facing more buffering time, and the performance would not be consistent across all the devices, and potentially you could lose customers, or customers might face a situation like this app is not working properly for me, or this app is not very good compared to another app. So these kind of situations occur often. So what does a CDN do actually? So for example, if you see in the right side page, the right hand side of the page, these are called as edge locations. So these edge locations would be available across the world. So there are five data center like images right here. So think it of like one in India, one in China, one in US, one in UK, and another one in Frankfurt, like France. So these edge locations caches the data which is available in a common data center and keeps them in the nearest zone which is available to the user. For example, if I'm accessing Netflix from my own home, what it would do is, rather than going to the US to fetch the content for me, it would go to Mumbai to fetch the content for me instead of US. The caching happens from US to Mumbai, and the data is stored locally in Mumbai, and I could access this data very fast in milliseconds of time instead of wasting seconds to view my content. So this is how CDN works actually, guys. It's very beautiful, right? Okay, so to put it more straightforward, let's illustrate this example actually. So there is a user called as Alice, and there are other users who are using the same app. So these edge servers which we talked about, right? So there were five edge servers, right? What it would do is Alice would make a request to the website, and the request would go to the edge server first. So the edge server would check whether the content is available locally, and if it is not available locally, it would go to the origin. It would fetch that content, and it would cache that content in its own edge server, and it would give the response back to Alice. The subsequent request made by other users, it won't go to the origin at all. So it would go to the edge server. Edge server would already have the content available with it, and it would instantly respond with the response. So Alice might have faced like 2 minutes, 2 seconds or 3 seconds to get the data at the first hit, but other users would get the data in instant milliseconds of time. So that is how CDN works, guys. Okay, so today's Friendship Day. So I would like to illustrate with another example as well, taking the local GDGs here. Uh, think of like Nagpur as a data center in their own location, and I'm accessing an app which is available in Nagpur data center in Coimbatore. So it takes around 1 second or 2 seconds to get the data. For example, I'm loading my website, so it takes 1 second or 2 seconds to get the data. But what my customers would need is they would need instant access to my website. So if I go to if I go to the browser and enter my website like praveent.com, so I expect that my users should get the response within milliseconds of time. So how do I do it? Okay, so this is taking long time, right? So what I would do is, might be Google could have an edge server at Bangalore. So what it would do is, whenever I make a request to a browser for my website, it would go to the Bangalore edge server and it would check whether my website is available there. And if the website is available, it would give me the response very instantly, and my users could access the website very fast. And if it's not available, it would go to Nagpur and it would fetch the data and cache it in Bangalore. So that's how it works. For another example, take it as Pune. So my users are in Pune and they want to access the data. For example, it takes around zero point 0.5 seconds. Instead of that, what I could do is I could use in Mumbai edge server for CDN, and Mumbai would cache it often, and I would get the data instantly from Mumbai instead of going to Nagpur. So that is how CDN works. To give a broader example for you. Okay. Coming to Google Cloud CDN, we talked about edge locations right now, but you should get a broader picture on how Google CDN works actually. Each cloud provider might have their own CDN, and Google Cloud is no different. If you see this image, there are various lines in green and blue. So these dots which are available in the world map are called as edge locations. For example, if you see India, you could see on New Delhi, you could see on Mumbai, you could see on Chennai. So these are the three edge locations available in our country. And parallelly, you could also see various edge locations available across the world. For example, if I hosted my website in an US North one region, what it would do if I set up a CDN is, it would take my website caching data to New Delhi, Mumbai, to every other edge locations across the world, whenever the first hit is being made. Once requests are cached, instantly users could access your application or your website in moments. If you see this green lines right here, it could be the C cables, and if you could see the blue lines right here, it could be the other networking mechanism used by Google. And Google very heavily invest in CDN protocols, and also on laying the physical wires and underwater sea cables. So they're making very huge investment, right? And also, if you have seen the news recently, they have made the started laying underwater sea cables in the Pacific and Atlantic, and they're connecting between the US and the UK using using seawater cables. What it does is, instantly in 1 millisecond, it could transfer up to more than petabyte of data. uh, Everything happens parallelly as we speak now. So once, as we speak now, one within 1 second, there would be a petabyte of data transferred between US and UK. So these are all happening behind the scenes. uh, this is what helping you to provide instant seamless experience for your applications and websites to your users. That's how it works. And also, Google has prior experience from 2004 on developing CDNs. They have 7 big applications like YouTube, Gmail, Google Photos, etc. So all these applications have more than 1 billion users, guys. 1 billion users is very big. And if a million users face downtime, like Gmail is not working properly, or I have think it of like I'm not getting the emails very instantly. So you want to get an email for OTP, and just imagine the Gmail response with the OTP message in after 1 minute or 2 minutes of time. So it would give you a poor user experience, right? So they're scaling in a very big scale, and even for such a big scale, CDN works very good and very properly. So that's the kind of investment they are making CDN, and also the feature they are developing, the team which is developing the feature. Okay, so let me go through how it works in GCP. If you're new to this content, it would be little difficult for you, but as we go through the demo, it would be easy for you to understand. Let me start with the left hand. I mean, I would start with the left hand side of the image and go through the right hand side. So there is a cloud DNS available. So think DNS like any DNS server. It could be Cloudflare, or it could be the cloud DNS in GCP, or it could be the GoDaddy DNS, anything else. So you would have a website and you would have an A record for that. You'd be configuring the IP address for the A record. So what we would do was we would get an premium IP from GCP, and we would be giving that IP to the cloud DNS for that A record in your website. And once you have set up that, I mean, using that premium IP, you could set up the cloud load balancer and also the CDN for your service. So once I have done that, so think like two users are there, one in Los Angeles and another one in New York. Both are trying to access your website. What it would do is the user accessing in Los Angeles would go to the Google Edge server at Los Angeles, and it would check whether your website is available in that own edge location. So once the data is available, it would beam back the response very instantly. Or else, what it would do is it would go to the backend service. The cloud load balancing would go to the backend service. What backend service is like? It could be anything like a Google Cloud Storage bucket, or it could be any container instance, or it could be an elastic compute instance, or anything. It could be also instances in our other cloud providers like AWS or Azure. It could be anything. It could connect any backend service with your service. And so the routing takes place through Google network. Actually, it would not go through other ISPs around the world. So it would be going through its own Google network, which we talked about earlier, like underwater sea cables or Google's own infrastructure. And it would go to the regional cache where your data is actually available. For example, my data is available in US Central 1 region. So my API is running in a compute engine platform, and it would go to the regional cache, and it would fetch that cache, and it would bring back to the Los Angeles point of contact. And once they get the data, it would automatically respond back to the user in Los Angeles. Similarly, to do for New York as well. uh, for example, your users are from various locations across the world, like India, like China or Australia. What it would do is similarly it would go to the Mumbai location, and it would be going to the Sydney location. So it would be going through that network and fetch that compute engine resource, and it would bring back the cache and store it in the edge cache, and it would respond immediately. So that's how it works. Okay, so to put it in a very simple picture, it works like this. So what you could do is your end user is accessing your cloud CDN, and the CDN would again go to the load balancer, and load balancer would fetch the appropriate data which you need to respond. For example, you could have load balancer setup, right? So you could have set up to respond with an image, or you could set up to respond with an API response. Anything would be possible with the load balancer. So a CDN requires load balancer, and load balancer takes care of bringing the data to the CDN. And the CDN, again, it works to make the cache available in various regions across the world. Okay. Okay, so we would start with a small demo so that I could show you how CDN is in GCP console, and it would be helpful for us to understand as well. What we would do today is we would create a basic HTML file, and also I have a video to upload. We would upload these two to the Google Cloud Storage, and we would create a load balancer and connect a backend service to get these data from the Google Cloud Storage, and we would set up Google Cloud CDN on the load balancer to take the advantage of caching available from the content delivery network. So that is what we are going to do today. And we would try buffering the video for the first time, and we would also try buffering the video for the second time. You experience how fast the video loads on the second time, because uh, the first time it is actually stored in the US network, and once I access it for the first time, it would be automatically saved in the Mumbai network. And the second time I'm hitting that video URL, it would be giving back the response from the Mumbai CDN. All right, guys, let's get started. Okay. So I create a new project actually, demo for cloud. Okay, I have created a new project and I think it's getting created. Okay, never mind. We could use the same project available right now. I'd go to the cloud storage actually. All right. Okay, so I'm going to create a bucket right now. So think of bucket like a Google Drive storage. You could create a bucket and you could add as much of files as you need, and you'd be paying for the amount of data you have used in the bucket. Demo for GDG Cloud. Hope that no one has used that name before. Okay, perfect. So yes, I've created the bucket right now, and by default, the bucket access is actually private. We need the users to be accessing the bucket from the public network. So what I would do is I would go to the permissions tab, and I would add an user to the permission. I would type it as all users and give the storage viewer access. Yes, allow public access. Cool. So I have added the public access for the users. So what I would do next is I would upload a file right here. So I could go to the downloads and I think I have a file here. Yes, I have an 18 MB file right now. So the upload has started. So parallelly to start, and I would like to go through setting up my load balancer. Okay, if you go to the networking part and you could find networking services, inside that you would find a feature called as load balancing. And go to the load balancing part. Okay, so here, perfect. I would create a load balancer right here. And I would choose HTTPS load balancing because you'd be accessing a video from the browser and I'd be allowing internet access. Cool. So I create a front end configuration first. I would give a name like demo for the cloud load balancer front end. And I need an HTTPS access. And I could create a premium network tier and create an IP address right here. It's fetching me a new IP address, so that takes some time. Yes, so the IP address is created. I will create a certificate for me, an SSL certificate. Give it as demo SSL. Okay, I don't want to upload my certificate. I want Google to create an own certificate. So I would give the domain name as demo.praveen.com. Okay, I would also need to map my certificate in my DNS. So I'd go to my DNS. It's kind of a bit slow, internet is, but never mind. Okay, so I'm going to my DNS and I'm going to create a new A record right here for demo. And my IP address is 349870. Okay, I have added my demo subdomain for this IP address and I have mapped it. And so the policy could be GCP default for SSL. And yeah, I'm pretty much done for the front end configuration. So host path, a simple host path would do so that I could access the location, data from anywhere. and I'd go ahead and create a backend configuration now. So a load balancer has both front-end configuration and also the backend configuration. Front-end configuration is like how the users would access that load balancer, how the public would access the load balancer. And after that, once the request has been into the load balancer, you'd need to configure in backend configuration to connect your services. If you go to the backend services drop down, you could see like backend services and backend buckets. So you'd be using an backend buckets today to connect your Google Cloud storage. So there is also a backend service available. So if I click the create backend service, you could see like backend type, and you have instance group, you have zonal network endpoint group, and also the internet network endpoint group. So the internet network endpoint group could be used for accessing the data which is available in other cloud providers or your own premises. An instance group would be like to connect your own compute engine platform. I would not be creating this today, so I cancel, and I go to the backend buckets and I create a backend bucket today. For example, demo backend bucket, and my cloud storage bucket, I would choose it one for the demo for GG Cloud. And you could see a drop down right here. So I just zoom it so that you could see. So there is an option called as Cloud CDN, and you have a checkbox called as Enable Cloud CDN. So this is all you need to do to enable Cloud CDN. You need not start coding and create various configuration files to enable your CDN. So nothing is needed like that. Once you click this button, Google automatically takes care of provisioning your resources and caching your resources in various edge locations across the world. So this is very simple, right? So once you create a load balancer, you could also create, uh, give the check for the enable CDN option. And once you create, the backend configuration is created. So you could review and finalize. And yeah, this SSL certificate is actually provisioning. And I'm just creating a new load balancer. Okay, my load balancer is being created right now. Uh, but parallelly, I would like to talk about the network tiers available in GCP. So there are two network tiers available. One is the premium network tier, and another one is the standard network tier. So we saw that we chose premium network tier while creating our IP. What premium network tier would do is it would route all the traffic from your application through the Google's own networking platform. So if you choose standard network tier, what it would do is it would go through other ISPs and other networking uh, hardware providers, and it would take some time for the users to go from point A to point B, and it would be going through various points across the world, and it would possibly add to the delay. If you go to the Google's premium network tier, it would directly transfer the data from one edge location to another edge location. So it is very fast, and your users would experience zero downtime. I think the load balancer is created right now, so I just try accessing it. Okay, I'm going to the cloud storage again. I think that my video is uploaded already. Okay, so I'm going to the demo for GDG Cloud, and yeah, so I think the file name is very odd. Just rename the file like s.mp4. Okay, just try accessing it. Okay, it's not responding. Okay, I think the SSL is not connected properly. It could take some time. So that is how CDN works, guys. So once I have connected my website and my SSL is provisioned, what it would do is once I hit this URL, it would go to the storage bucket location in the US region, and it would take the video for me from there. For example, it could take some 20 seconds for me to buffer the entire video from that first hit. So once I have completely watched my video, and for example, if my friend, I am sharing this URL with my friend or you guys, and what you would experience is the buffering time would be very less compared to the first hit. For example, it could be 20 seconds at the start, but you could get the video buffering available within 5 seconds or 10 seconds if your internet connection is very good. Since this is the reason is because the data is being fetched from the Mumbai edge location instead of the US edge location. That is the beauty of CDN, guys. Maybe we could wait for another 2 minutes to check.
Hello, Praveen. Sorry to interrupt, but can you please zoom in your browser? People are commenting that they are not able to see the text.
Okay, you need me to increase the size, right?
Yeah, yeah,
Perfect.
yeah. I guess this should be fine. Once again, sorry to interrupt.
Yeah,
Yeah, I think.
perfect. Okay. So parallelly, while being the SSD is being produced, I could go to the cloud CDN part actually. So if you go to the cloud CDN subsection in the network services, you could see the cloud, the load balancer I created right here. So once you click it, you could also see the summary of how it works. Yeah, the certificate is being provisioned. So if I go to the monitoring, I could see the RPS for the backends within this load balancer. For example, I could see how much delay the customers are facing in accessing my video or my website for a wide range of period. Like I could see for 6 hours or 30 days, and I could see how the latency is being plotted for various time zones and various users. Um, yeah. Okay. And I could also go to the cache invalidation section right here, and I could give my path here. For example, I could give slash demo dot star, and demo dot mp4, and what it would do is it would invalidate the caches available various edge locations, and when the user accesses it next time, it would be freshly obtained from their own data centers. So that is the use of cache invalidation. Okay, it's still being provisioned. Maybe I could go ahead with the slides, but we don't have enough time. Okay. Let me talk about the benefits of using Google Cloud CDN. As we talked before, it is very blazingly fast, and your users won't face much of downtime at all. And you need not worry about caching the data to the edge locations manually. So once you have checked that checkbox, enable Cloud CDN, Google automatically takes care of caching your data to the edge locations. You need not take care of anything after that. And yeah, having their own experience for around 10 to 20 years, Google also has employed all the DOS protection features available in various edge locations, various DNS locations, and also on their own data centers as well. So if the users are trying to do a DOS attack, it would be prevented. And you need not worry about the SSL provisioning too. So you need not set up Let's Encrypt certificate to get your free certificate, or you do not pay for any SSL providers to get your own certificate. So nothing is needed. Once you give the domain name and you map your IP address to the DNS, it automatically takes care of SSL provisioning and also renews it automatically for you. And Yeah, if you choose a premium network tier, the network could be directly connected between zones, be it US to Mumbai or US to Frankfurt or US to Sydney. It is directly connected, and the data is very fastly available. And the final reason is it simply works. It simply works beautifully, and you absolutely love the feature if your product is scaling to a very high level of users. Okay, comparing to various CDNs available across the world, so you could see from the image itself. So Google Cloud CDN responds very fast, and it gives the query back in 66 milliseconds for a particular location, in average location across the world. And other CDNs are very much behind like CloudFront and AWS. Sorry, CloudFront CDN, Azure CDN, Akamai CDN, etc. For example, Hotstar uses Akamai CDN widely, and it is very. Comparing to that, Google Cloud CDN is fast. Okay, we talked about it earlier. It is the DOS protection. So this is called as an DOS attack. So once an attacker creates a bot, and it would automatically go to the DNS to fetch the records, and the bot would automatically go and try to query the data in the edge location. And the edge location has its own intelligence and blocks such kind of attacks, and your users won't face downtime due to that. And also the SSL provisioning. So it automatically takes care of SSL provisioning, and you get the best security available on the CDN. Even if you have not set up your own SSL server, SSL certificate, and you're accessing your via HTTP, so CDN automatically encrypts the data from the CDN network to the data center. So no data is compromised between the CDN and the data center. Only the data is publicly viewable from the edge location to the client devices. Okay, let's quickly check it. The SSL is provisioned. Okay, I think SSL is provisioned. Such key. Okay. I think there's some issue. Sorry. Okay, this test.mp4. So yeah, it is working right now. So I've gone to the test.mp4, and you could see that the buffering takes place right here. So you could see, it is buffering right now, and the data is not being fetched very fast. So if you go to the network tab right here, you could see that it's taking, let's wait for the video. Okay. So let's track, like for 8 MB, it has taken 30 seconds right now. So I don't know why it is taking so long. Okay, if you see right now, it has already passed, various buffering time. See right here. It is buffering very fast right now. For example, if you see in the previous load, it was taking 30 seconds 30 seconds for 8 MB of data, but for 5.5 MB itself, it is being done in 18 seconds. So considerably, the performance has improved. And once the various users are trying to access your website and your stuffs from various locations across the world, it eventually gets better and the process would get even faster. Okay, I'd go to the load balancer again, sorry, CDN again, and see the metrics right now. Okay, I think we don't have a very wide range of data, but you could see it first right here. So for the first load, it was taking around 0.07 millisecond to respond, but after the caching takes place, it only takes around 0.02 seconds. So that's the power of CDN, guys. I think we're done with the presentation today, and thank you so much for joining. I think it's also time for to wrap up. Have a happy Sunday, guys, and let me take some questions if you have. Thank you so much.
Thank you so much, Ravi. Yeah, so so there is a comment from Rohan Singh, who is asking, is Syrian effective for all kind of websites?
Yes, it is applicable for all kind of websites actually. So we have hosted the website and the video right now from Google Cloud Storage. But what you could do is you could also host the website from an compute engine or an Kubernetes part, and also you could create instance groups and host it via that. So yes, it is applicable for all kind of websites. You could use it for all kind of websites. But personally, I would suggest that once your scale is getting very higher, I would be suggesting to go with Cloud CDN, because even the CDN actually attracts pricing for GCP usage. For example, if you have 1,000 users or users across the various locations in the world, I would be personally recommending CDN to be used.
Yeah. So after that, there is a question from Shubham Chopra, who is asking, what is the difference between CDN and caching service?
Okay, so yeah, a caching server is an edge location, but CDN is a wide concept. So, I mean, we have a concept called as POP, point of the, and what you could do is the CDN. What it does is it caches the the data from various data centers to the edge locations automatically. While as a caching server is a small entity in the CDN itself. So it is the term which we call use for the edge location.
Okay, so after that, there is a question from JP, who is asking how CDN works with dynamic websites.
Okay, yeah. As we talked earlier, we could invalidate the cache periodically. And also, if you go, I would just share my screen once again so that I could show you a small demo on that. Just share it. Yes, I think I share my screen. Guys, I think it's the wrong screen share right here.
Oh, it's my bad.
Yeah, no issues, no issues. Okay, if I go to my cloud storage, actually, what I could do is I could go to the file which we played right now, the test.mp4 file, and if I go to this edit metadata part, you could actually have a field called as cache control. So once I could give the cache control like maybe 1,200 like that. So what it means is 20 minutes. So once I give 1,200, it would be giving the cache control metadata as 20 minutes. And it would also notify the edge locations that this data is valid only until 20 minutes. So once the 20-minute part is over, it would automatically clear the cache in their own edge locations, and the subsequent request to be fetched from the data center again. That is how it works. So you could control it via the cache control headers while responding to the content.
Yeah, so there is some next question from Mohan Pawar, who
Okay.
is asking that can you throw some light on Open Connect versus account?
Okay, so I'm not very pretty sure on that. I hope that those are various CDNs available. I'm not personally on various other platforms, so I'm just getting started on GCP CDN alone. Uh, so sorry. Sorry, Mohan.
Yeah, no worries, no worries. Yeah, so there is one question from Saurabh. It's from us. It's for us. So, can you please create Telegram or WhatsApp group that notifies me about time to time about webinar? Yeah. So the best thing you can do is follow us on Twitter, right? Follow every GDG on Twitter. It's a quite hefty task, but you can do it. And if you are more interested in cloud next sessions, you can just subscribe to this channel and turn on the notifications. So you'll get a personal mail and notification whenever we are scheduling anything in upcoming weeks. So we still have 6 more weeks to go before we end CloudNet extended for on air, hosted by 12 plus GDGs in the India-based region. Yeah, so thanks for me. It was a fun session. I'm pretty sure that I am also going to use this thing in the upcoming days. CDN on GCP, and you helped me with that. Yeah, so thank you so much. So, how is your experience today on this Cloud Next Extended on Air on this session?
Yeah, but it was very great talking, and yeah, sure, I would help you with that on your own journey in the future. So no worries on that. So coming to your question, it was very great actually being hosted with you guys, and the host actually take care of everything behind the scenes, and also they are personally being in touch before the session starts. And yeah, as a speaker, I felt that it was very good to be hosted right here, and also the platform is very good, and there is no disturbances across the presentation, and the speakers are also, I mean, the audience are also very attentive in YouTube, and they're asking very good questions. So happy that I was a part of this today. It went good.
Yeah, so thank you so much. I would like to invite our next speaker, Vishal, to the stream, and thank you so much, Praveen, for joining us. Yeah, so hi, Vishal. How is it going?
Hey, I'm good. I'm good. How are you?
I'm good. So, just a moment. Apeksha is saying thank you, sir. So, thank you so much for joining the stream first and
Hmm.
sticking till the end. I'm pretty sure there are some interesting things at the end of this session as well. So, let's talk with Vishal a bit and then we can start the session. So, I heard that you are working on some interesting platform or we can say open source stack. Can you explain that? I heard its name is Vision, Fisher, right?
Yeah, yeah,
It's very cool
sure.
name.
So Fission is a function as a service platform on top of Kubernetes. Think of it like Lambda or Google Cloud Functions, but it runs on top of Kubernetes. That way, you can run it anywhere there is Kubernetes, so to speak. It basically simplifies the developer experience in terms of using Kubernetes without having to understand a whole lot of Kubernetes, and also allows you to run workloads based on events. Pretty much like you do in other fast platforms.
Yeah, I guess that's interesting thing. So you can pretty much run your own functions on your own
Yeah,
server.
yeah.
Yeah, that's very much interesting. Can you tell us a bit about yourself, where you work, and what are the technologies that you are interested in?
Sure, sure. So I'm CTO and founder at InfraCloud Technologies. We primarily focus on Kubernetes and the cloud native landscape. And I personally have been involved pretty much in the Kubernetes and the ecosystem around it. It is Prometheus, service meshes like STO and other technologies. And my personal interest basically lies in serverless space is one. And generally, how do we make adopting Kubernetes easy for the enterprises is something I know. I'm pretty kind of involved in deeply sort of.
Yeah, so I guess without wasting much time, we'll have a awesome one more chat at the end of your session.
Sure.
So without wasting any time, let's get it started on the session. Thank you everyone for joining. I'll be back at the end of the stream to annoy.
Cool. All right. So we are going to talk about using Scaffold for building and deploying applications to GKE, the Google Kubernetes engine. Now, quick introduction of myself, Vishal Biani, as part was introducing me as well. I'm CTO and founder at InfraCloud Technologies. We run the Kubernetes Pune meetup almost for 4 years now, every month, and have been doing it virtually for last of course, for odd months since the COVID-19 outbreak. So please join us on the meetup of Kubernetes Pune, and check out some exciting topics that we keep talking about there. So let's understand what we are talking about today, what we are trying to do. So if you look at any non-trivial application today in the enterprise or even in a startup, it consists of a bunch of components. First of all, it might have a couple of microservices at the least, and it might be using let's say a front end, a cache service, a message queue, a database, and stuff like that, right? And all of these need to function together with each other to be able to talk with each other and deliver value to the end user, so to speak, right? Now, let's say as a developer, I have this new shiny idea that I want to introduce a new feature in the product catalog service and add some fancy information so that the users can use that information. Typically, what happens is you might change the product catalog service and test it with one component or two components. But for this to work really seamlessly, the contracts have to be very clearly defined, the unit tests have to be very clearly defined, and your testing strategy has to be really strong for you to be able to decide only change this service, test it out, and push it out to production, right? And the reality, of course, is always slightly different. A typical any non-trivial application goes through multiple levels of testing, right from your unit test to functional test to integration test, and eventually some sort of non-functional requirement test before you put it out in front of the end user, so to speak, right? And again, this has been traditionally there, but of course, a lot of things have been evolving in the last few years, especially with the kind of tools people have been using, and things have been moving sort of further. So again, the reality varies, as I said, in a spectrum from organization to organization, from teams to teams, and even from technology to technology. So unit test coverage again might vary from organization to organization. Some organization might have really test coverage, and that might be a really good enough indicator to say that I'm going to put this service into production. A well-defined contract also has to exist between multiple services. So, for example, if you have one microservice talking to other ones, you need to decide and have the contract very well defined. And of course, like many places, what ends up happening is you basically define or deploy the whole stack in a QA or stage kind of environment before you really go to production, so to speak, right? So it is almost like people are building actually microservices, but the testing is happening really like a monolith style, where unless you define all the microservices together and deploy them in an environment, you really don't take them to production. Now, with Kubernetes, I think the challenges, I wouldn't say they don't multiply, but definitely there are a few additional challenges, right? For example, if I'm a developer, I'm deploying a microservice into Kubernetes, and it uses a few secrets, a config map, maybe a couple of volumes, and then I have also my manifest or Helm chart, which is nothing but infrastructure code, really, right? How do I test all these locally? That is one of the challenges I do face, because I can't really simulate the secret part, or I can try to simulate, but it may not be as perfect as it could be, in production kind of environment, so to speak, right? So as a developer, my goal is that I should be able to deploy my services along with potentially other services in an environment which is as close to production or production-like as possible. And the second most important aspect is the feedback loop should be fast, because I can get the environment where I have everything else running and I want to deploy my service, but I don't want to wait for, let's say, 30 minutes or 20 minutes before something is available for me to test and, again, change and, deploy again, sort of, right? So that fast feedback loop is extremely important, because as a developer, we continuously iterate, right? And when we iterate, if you don't get the feedback fast enough, it is not very productive. It is also very frustrating as a developer. So those are two key aspects that we are looking at, and then we'll see how these problems get solved as we go further down the slide. So I think there are two goals here. One thing is I want a cluster-like environment, which is as close to Kubernetes, but at the same time, I want it to be lightweight, fast to boot and tear down, so that I don't have to spend time waiting for it to come up. And it should be as close as possible to a real kind of cluster. And the second part is I should be able to define a workflow, like, hey, take my source code, build an image, deploy it here, and then do this. And again, this has to happen like almost in real time, so the feedback loop has to be really fast. So with those two goals, let's look at some of the options which are available out there. Now, when it comes to clusters, you might have heard of Minikube for sure. Minikube runs basically on a VM on your local machine, and then it creates a Kubernetes cluster within that VM. And it's a single node cluster, and you can use either a virtual box or a HyperKit driver to make sure your virtual machine is spinned up, and it's a great option in many use cases. Now that is good part. There are some challenges though. For example, you can't do a multi-node cluster. It's a single virtual machine with single node, so you can't really simulate multi-node cluster, so to speak. It also needs a lot of resources because you're basically spinning up a VM, so at least 4 gigs of memory just for the VM. That means your laptop has to be at least 16 gig memory and 3-4 CPUs at the minimum, so to speak, right? Other option is K3s and K3D. So this is from Rancher Labs. K3s is basically a kind of toned down version of Kubernetes, if you have to call it that way. It is single binary. It works really fast, pretty good to boot up and tear down. But there are some challenges. For example, some components might be missing from the upstream Kubernetes. It is great for IoT devices, but also great for local CI/CD workflow. I haven't used this a lot, so I can't speak a whole lot about it. The other option is Kind. You might have heard about it, Kubernetes inside Docker. So what this does is basically spins off multiple Docker containers on your machine, and each of those Docker containers is acting as a node of Kubernetes cluster. So technically, you got like a multi-node cluster on your local machine, and it is super lightweight and fast to spin up new clusters and destroy them as you need to, sort of, right? Now, all of the options that I looked in last 2-3 slides inherently require you to have a very powerful machine. Unless you have, let's say, 16 gig of RAM and those kind of resources, I don't think you can technically spin up a cluster and then add your microservices and databases and whatnot other components to be able to test locally, right? And that's where what a lot of people do is they basically use a cluster in the cloud like GKE, and typically they get one namespace in that cluster, and they can test all their changes in that cluster. Now, of course, some teams might say, hey, I want my own cluster because I don't want to get affected by somebody else's workloads running in the same cluster, but that's not going to be super cheap. So idea is to use a single cluster which is shared by a larger development team, and every team or every small team gets their own namespace in which they can deploy, build, and iterate their applications, right? So I think we have sorted out one problem, which is having a cluster which is production-like, production kind of close to production. Now let's look at the other part. How do I build a workflow so that I can build, deploy, and test my images? Again, in the workflow space, there are a bunch of tools. One is Garden. So Garden is a tool which tries to solve the same problem where you define all of your application into a manifest, and it builds and deploys from your local machine to your cluster. Now, one of the cool things I really like about Garden is something called a stack graph. Now, stack graph is a very intelligent way to determine what part of your applications actually change and only deploy that change part and not deploy everything all over again. But what I really don't like about Garden is the quite heavy configuration. So for every module and submodule that you end up defining in Garden, you need to have one large declarative information in that module, and it's kind of very tightly coupled with your code base, kind of ends up almost cluttering your code base, if I have to call it that way, right? The second tool is Tilt. Tilt again solves very similar problem where you can build a configuration information of your application, and then Tilt can deploy to a cluster. It works with manifest files and Helm charts, but some of the use cases that I had personally, I didn't could really get those done in Tilt, so to speak, because it has a very limited number of plugins, at least last time when I had looked at it. Now, third option is Scaffold, and Scaffold is what we're going to talk about today in our session, like rest of the session, so to speak. Now, what I really like about Scaffold is it has a CLI, but also has a manifest-driven, definition. It has an opinion about how your pipeline should look like, but in that pipeline, everything is pluggable. So although it lays out a template, you're not forced to use any specific tool. You can plug out or plug in another tool and use that tool, so to speak. And each phase has a plugin. There are already built-in plugins. You can potentially write custom plugins, but those plugins allow me the flexibility to use what I want. And last but not the least, it allows stuff like log tailing, port forwarding, file sync, because inherently when I'm testing and debugging applications, I want to be able to do debug. I want to be able to real-time change files and see what the change of what the effect of that change, so to speak, right? Now, there are of course other tools. There have been other tools like Draft and Casing and GitCube, and also Telepresence, for example. What I personally felt was each of these tools was trying to solve a silo problem and not taking a holistic view of things end to end, and that's where I really like Scaffold, for example. So what we'll do is we'll understand what a scaffold file looks like, what are the different components of a scaffold file, and then what we'll do is we'll run a simple application that I have in my machine. We'll see how it deploys and builds and stuff like that. and then we'll look at scaffolds detail again. Now, scaffold has a very defined pipeline which consists of multiple stages. So the first thing it wants to do is understand what files you are changing on your local machine and detect those source code changes. Once the source code change has been detected, you want to build the artifacts. So it could be building, nowadays, of course, it's kind of container. So building from your source code to a container. Once you have done that, you want to test it locally or in cluster, and then tag it with either a tag, based on the naming scheme that you're following. And then render those manifests and deploy those manifests into your Kubernetes cluster. And once it has been deployed, you want to look at the logs of your application. You want to do port forwarding so that you can do more debugging if there are any issues in your deployment, so to speak, right? Now let's look at each of these phases in slightly more detail. What are the plugins available in each of the phases, right? So when it comes to build, there are a bunch of plugins available. There's Docker plugin, which basically uses your local Docker daemon to convert your Docker file into a Docker image. It also comes with a plugin for Jib. Jib is again open source tool from Google, which allows you to use Java source code or Java application to convert them directly into Docker images without even having to write Docker file. So all you have to do is point to a specific format or a structure of Java application, and it basically builds out a very efficient Docker image out of it. There is also Bazel. Bazel is a very popular tool used by many organizations to do build, especially for monorepo kind of applications where you're building multiple services under a single repo, and you want to do a lot of optimizations, there. And Bazel, Bazel is very useful there basically. There is also build packs. So build packs is like an intelligent way to detect what is the language you're using, what is the format you're using, and again build out images without you having to understand the whole details of Docker file, how to do write Docker file and stuff like that. And you can also do custom. You can technically call a custom shell script, which is doing all the building for you, so that you can maybe move all your existing code base without having to adopt or change anything, so to speak. When it comes to testing, Scaffold supports something called as container tests. These are basically, I believe, running inside cluster, and there is again open source tool. How do you structure those tests? So right after you deploy your application, or maybe right after you build your application, you want to test something, whether the build has been fine or the deployment has been fine. You can use these tests to make sure they're actually really up to the mark, so to speak. In terms of tagging, again, there are various strategies that Scaffold supports. You can use SHA-256 of your code base as a tag, or you can use git commit, or you can come up with a template. A lot of people, want to have a very elaborate naming scheme, whether it's a combination of semvar and date and something else, but some sort of template that you want to use. Some teams also want to use just date and time as a tag for your Docker image, and there could also be custom requirements that it supports actually. When it comes to deploying, as of today, Scaffold supports kubectl, so you can technically just do kubectl apply with your manifest files. It also supports Helm. Helm is a package manager for Kubernetes, so all it takes is a chart and all the dependent charts and deploys them to a cluster. And then there is Customize. Customize again follows a kind of manifest on the steroids approach, where you have the base manifest and then you have patches for every environment or every customization, and then you apply those. And lastly, once you deployed your application, you can do look at the logs of your application. You can do port forwarding. You can so the reason to do something like port forwarding is, let's say I'm running my UI on my local machine in my IDE, and my backend is sitting in the cluster. So I want to forward the backend API port to my local UI application, so that I can quickly change my UI and look at the effect locally and have my backend service deployed on the cluster, so to speak. So now, if you look at the pipeline, the very similar step that we looked at earlier. So we have the file sync and detecting code changes on local machine. For building, we have support for Dockerfile, Bazel, and Jib, and there is a bunch of others. You can do testing of artifacts. You can do tagging using multiple strategies. You can push the artifacts to a Docker registry, and then you can deploy with multiple options, basically, right? Now, this is the kind of optionality that Scaffold provides, and you can say, hey, I want to build locally with Docker daemon. I want to tag with SHA-256 as my hash, and then deploy using kubectl. Or I can say, hey, you know what? I want to actually build my source code into Google Cloud Build, because that's a great service I want to use, from converting from source code to binary, and then use git commit IDs as my tagging strategy, and then I want to use Helm as my deployment mechanism. So if you look at it technically, it provides you a framework. It provides you a bunch of plugins available. You can pick and choose what works best for your case. For example, a lot of people also use Canico. Canico is a tool we'll talk about slightly later for building your source code to a Docker image inside the cluster. So you don't even need to do converting your Docker file and source code into a Docker image locally. You can do all that in cluster as well. Cool. Lastly, you also can use something called as environment. So technically, any application again, goes through like dev, QA, stage, and production when you deploy into any real kind of bigger enterprise, right? And you want to have profiles to say that for dev, use these kind of resources, use these Docker file, or don't use certain components and stuff like that, right? For example, you might say for dev, I have a very different Docker file versus I have a different one for QA and environments beyond that, so to speak. It also detects your Kubernetes clusters, so it can detect stuff like kind and minikube, because typically what happens with kind and minikube is you don't have things like you can't provision a load balancer or you can't provision a volume, and you need to treat some of those things slightly differently, and that is something Scaffold detects automatically and tries to make some adjustments so that you don't have to do all that configuration and all that work beforehand, so to speak. Now, what we are going to do is, I have this project called Fission, which Parth was mentioning, earlier in the introduction. Fission is an open source, fast platform on top of Kubernetes, and we actually use for Fission Scaffold, for building and deploying application into Kubernetes cluster. So let me actually probably show the actual code and try running it, and then we come back to the slides later in the flow. Cool. Let me share my ID. So the project is actually on GitHub. It's called GitHub in the Fission repo, Fission project. And what we are doing is we are having a scaffold file in the code base defined. Now, if you look at the scaffold definition, there are a bunch of components. We talked about build phase earlier. We talked about deploy phase. So there are two phases at the very high level, and you define the base information, in terms of the API version, the kind of scaffold being configured, as you define in any standard, Kubernetes YAML format. Now, within the build phase, you will see there is a subsection called artifacts. So I'm saying these are the artifacts I'm wanting to build as part of my application. And as you can see here, I'm building 3 artifacts. All of 3 are images, Docker images. And for all 3, I'm using Docker, my local daemon, to build out those images. So I have, one image being built for Fission bundle, other image being built for a component called fetcher, other image being built for a component called, pre-upgrade checks. So I'm basically building these 3 images. And when it comes to tag policy, I'm saying I want to use environment template. And environment template is use the name of the image and tag of the image. This tag I have to supply from outside, basically. Now that is the build phase. Now once build is done, I'm doing deploy. And for deploy, I'm using Helm here. And within Helm, I'm first defining a few flags in terms of timeout, in terms of, for upgrade, always pass the install flag and stuff like that. And then comes the release part. So I'm naming the release of my Helm as Fission. And the chart is, in this directory in the charts, Fission all. And then use the values from the same directory called values.yaml file. And I want to deploy this to namespace Fission. So I can again customize this here and deploy it to a completely different namespace. And then I'm overriding a few specific values. So what happens is these values that I'm overriding here gets merged along with the values from the Helm chart. And that becomes your eventual values file. And then I'm specifying a few more options, like wait, do you want to recreate parts? Do you want to use any image strategy and stuff like that, right? So this is the basic definition of, my scaffold file. Now let's go ahead and run it and, see how it works. All right, so as you can see, right now I'm in the Fission namespace. Some pods are running, which have been deployed about 23 minutes before. And if you look at the current list of applications which are deployed in my cluster, there is Fission, and then there is Prom, which is Prometheus, basically. For some reason, this shows failed around about 30 minutes ago, but let's see if that gets fixed. And what I'm going to do here is I'm basically going to run my scaffold. So I have also run it previously, but I'll want to quickly show you some of the things there. All right. So let me do this. All right. So I'm providing a tag called Theo4 because I want to provide that from outside. And as a developer, I want to always upgrade it, kind of update it, the tag number by another number, so that I'm using the latest tag and latest image, so to speak. And then I'm going to, do scaffold run. What this does is basically reads my scaffold definition, generates tags, generates the, checks if there is anything in the cache. Now, there's nothing in the cache, so it's started building the image. So the first image that it is building is Vishalbiani fission. So if you look at it again here, it is right now building the first image using the first Docker file and corresponding artifact basically. Now this is going to take a while because it's going to build all those 3 images and then push it out. So what we'll do is we'll come back to it. Let's give it a few minutes and we'll come back to that. Cool. So as I was mentioning, I'm building multiple images. I'm using Helm to deploy the cluster, and I'm also setting Helm values, for building fission to scaffold. Cool. So one thing I personally feel is coming of age is something I call as in-cluster development, and I believe that is kind of the future. Let me explain what do I mean by that. So nowadays you can use things like Canico or Builda or Google Cloud Build to actually build your source code to image inside the cluster. So you don't have to build things locally. And what happens is you basically upload your context, which is your code repository, once you are done developing, to a S3 bucket or some S3 compliant bucket. And Canico or Google Cloud Build or none of these tools can actually build all of your applications from source code to binary inside the cluster. Secondly, you might have seen the announcement, about code spaces from GitHub, which is basically a browser-based IDE. So technically, I can again write my code in the browser. I don't need to install even VS Code or anything like that on my local machine, right? And there are other options also, like, there is also REPL.it, there is Gitpod. REPL.it is great for, developing small applications with single files. Gitpod is a little more full-blown in the sense it runs your applications, or it actually runs your browser in a pod in Kubernetes cluster, and you get to access that in the browser, basically, right? So now I can do also development in the browser. So I have built my applications in the browser. I'm developing in the browser. And of course, deployment always has been happening in the cluster. So all of my build, deploy, and test cycle can happen all in the browser without, actually requiring like a very powerful machine. And once I have started doing that, I can actually do a bunch of things. For example, I can do, stuff like A/B testing, or I can do tracing, and I can really focus on these things which are more important than, having to set up my local environment and really optimize for that, so to speak, right? So I think the eventual goal is to really make it easy for developers and make it easy to build, deploy, and make it run. So let's go back to terminal and see what's happening. I think it has built the first image. Let's see. Yeah, first is done. Second is going on, which is picture right now. It is of course been using Docker on my local machine right now. It is still to build the third image, which will take another minute or so. Just let's watch on that. We recently started using fission scaffold actually for fission, and that's why we only have kind of basic scaffold definition in place. Some of the things we really want to do is build inside the cluster so that the build really happens seamlessly without me having to look at what's happening with my build. We also want to do stuff like don't build the entire Docker image, just build the Go binary inside my Docker image, and simply copy that binary into the container and restart the container. Also stuff like port forwarding and probably log tailing is something we haven't implemented yet in fission scaffold definition, but that is something kind of coming up in the next few releases. I think it has almost built the third image as well. Just a couple of steps left. All right, so as you can see, it has built all 3 images now, and now it is pushing the third image to Docker registry. And right after it has done pushing images to registry, it is actually going to kick off the Helm deployment. All right, so it has tagged it, pushed it, and now it is starting the deploy part of it. It has downloaded all the subcharts which are required for the fission chart, so to speak. And if I go and look at the parts here, we will see that some of the parts have started getting recreated. let's keep watching that. Yeah. So the old pods are getting deleted, the new pods are getting created. That's just basically Helm, trying to deploy the new version of the chart, basically. Yeah, we can see some comments are running, some are still, waiting for the ones to come up, some are in creating stage. All right, I think most of them are in running stage now, last 30 odd seconds. Now, if you look at the Helm list, I'm sure Helm is still working, as you can see in the console above, and that's why you won't see the latest release. Now, I think last time when I deployed around half an hour ago, what probably happened is it timed out. I don't know for what reason, maybe because one of the services didn't come up properly. It's probably the MQ trigger, the NAT spot that is causing issue here. But eventually, it has deployed the pod, so that means my release is actually done technically. Although it is going to say failed in the Helm point of view, there is probably a small bug in my definition right now still. Yeah, there is something wrong with the NAT spot. I need to get that fixed. So as you can see from developer's point of view, as a developer, what I do is I change the code and I kick off a scaffold run, so it goes and deploy in the cluster, and I keep rinse and repeating the same cycle over and over and over weekly. So that's about the story of scaffold and fission, I guess. One last, or let me go in full screen mode here. So as I said, I think the in-cluster development is really becoming like a thing. In a few months, probably in a year's time, we should be in a state where I'm developing all of the development in my browser. The build, deploy, test, everything is happening in a cluster which is running somewhere. And I don't even need to do any setup locally. And I'm really waiting for that world, to be reality. Cool. One last, kind of plug. Fission is the open source project. You can go and check out on GitHub if you're looking to do your first open source contributions, or if you're looking generally to do open source contributions. We have a lot of good first issues for people to contribute, and we are happy to help on the Slack channel. Also, BotCube is another open source project from us. It's a bot for Kubernetes. So you can talk to Kubernetes from Slack, Mattermost, Microsoft Teams, and any other chat platform. It also does a bunch of auditing policies and those kind of stuff. Again, open source platform. It's a great project for a newbie or a first time starter contributing to open source, because it's not like super complicated to get started. And that. So those are the links that you can see in the deck. And I think that's more or less in terms of the content. Thanks for listening to me patiently.
Yeah, so thank you so much, Vishal, for this awesome overview of your project Fission, as well as how you can use scaffold and everything. And that's very great with you. So yeah, so let's talk a bit about questions. So I don't think audience has any questions for us at least yet. So till then, we can just start talking about like how did your developer development journey started, and what's your like how long do you want to, like how far you want you see Vision going in upcoming years.
Sure. So I actually did my mechanical engineering back in the day, and I started working for a large system integrator company. Did my development in Java, and being like a code kind of programmer, developer, whatever you want to call it, right? At some point around 2009 or 10, I attended Google Dev Fest in Pune only, and I came to know about Google App Engine. And Google App Engine was exciting new technology back then, and I got so fascinated about it. I started doing work on that on my own. Wrote a few articles for a couple of websites and stuff like that. And then slowly I, got introduced to things like, Docker. Docker was very late, of course, but like Chef, Puppet, Elasticsearch, Jenkins, and I got more interested in DevOps side. And that's how, here I am now back to being a programmer, but on the DevOps side, or, building tools for infrastructure, so to speak.
Yeah, DevOps is very interesting field indeed. So even so we have questions from Mohan Pawar. So can we configure ingress logs with scaffold?
Yeah. So inherently, what scaffold is doing is deploying your Helm chart. As long as your Helm chart has a ingress definition, and as long as you have an ingress controller deployed in your cluster, it's just gonna work seamlessly. I don't think scaffold does anything specific to ingress or ingress controller. Uh, does that answer your question, Mohan? Let me know if you have a
Uh,
follow-up question or anything like that.
yeah, sure. So till Mohan is replying, let's continue with our chat.
Sure.
So
Sure.
basically, how did you find this whole ecosystem in every this many communities coming together and hosting event for around approximately 9 weeks? I guess this is one of the kind event in India where this many
Yep.
communities are coming together and hosting events for this long. I guess. So how
Yeah.
has been what? Yeah. So
Yeah, it's super exciting. There is so much to learn. There is so much new stuff happening, and it makes us as developers more productive. So I'm excited, to see the new ways of doing things and new technologies, being discussed.
yeah, it's awesome. And I'm really looking forward to using Vision and deploying our own functions. All right.
Absolutely.
Yeah.
Yep. Yep.
Yeah. So I guess we are at the end of our stream for the day. You guys can subscribe our channel for future updates. Don't forget to hit that notification button, and so that you can get. Yeah. So Mohan has replied. Thank you so much for answering this question.
Cool.
Yeah. So thank you so much, Mohan, for at least coming to our stream. Yeah, so you guys can hit that bell button so that anytime we are scheduling a new stream, you will get an awesome personalized notification in your mailbox and your Android or iPhone, whatever smartphone. And next week is going to be handled by GDG Mumbai, or they like to call it GDG Mat and GDG Cloud Mumbai. Right. So look forward to seeing you all on the next stream. Please make sure that you subscribe to that Twitter GD Mumbai and GD Mad Twitter channel so that you can get updates. Right. So I guess that's it for the day, and happy Raksha Bandhan and happy Friendship Day to you all. Thank you so much for joining the stream. Have a great day. Bye bye.